Hi students, this is Mr. Lou and I am your 7-Minute Sensei, where I attempt to explain everything that you need to know in 7 minutes or less. Today I'm going to talk to you about an assignment on computational thinking. Computational thinking is a problem-solving method. Some of you may be familiar with the scientific method. Some of you may have heard that an essential skill today is good critical thinking skills. Today, we're going to talk specifically about computational thinking and the 4-step process to solving a problem. I'm going to use an example actually from 1973. In 1973, OPEC, the Organization of Petroleum Producing Countries, decided that they wanted to embargo the United States. That simply meant that they were no longer going to ship oil to this country, which in turn meant that we could not produce gasoline, and ultimately we had a gas shortage. So the government had to decide how to ration gasoline. Now today, we don't have that same problem, but we have a pandemic known as COVID-19. In COVID-19, in our situation today, we have to determine which services are essential. So, flipping back to this gasoline rationing problem here, let's walk that through computational thinking to give you an idea how you might apply this to today's situation. Okay. With computational thinking, we begin with decomposition. That's taking a huge problem and breaking it down to smaller chunks, smaller solvable problems. So in the case of the oil embargo, we had to decompose this problem and say, you know what we need is to ration our gasoline in a fair and equitable way. The second step is to observe patterns. By observing patterns, hopefully we can use these observations to come up with a viable solution. So in this case, we saw things such as we've got large vehicles, small vehicles. We've got all our vehicles here have license plates, and back in 1973, the plates either ended with an odd number or an even number. By the way, this is before vanity plates. We had regular customers and we had customers. We had customers that had the capacity or the wealth to buy as much gasoline as they wanted. And then we had customers who would scrape up all the change that they could find to buy gasoline. But keep in mind that our goal here, and this is where we look at the abstract, our goal here was to find an efficient, an egalitarian, a populist approach to rationing the gasoline, reducing traffic, avoid riots, and avoid chaos. Okay, so that's the abstract. The abstract is really taking those patterns that we observed and really just filtering those down into really what matters most and what will really help us solve the big problem. Okay, and then finally the algorithm. In this case, we are looking for a set of instructions, a recipe, if you will, that we can give to the computer to solve. Okay? So this is how it would look. We could say, computer, you are to determine whether or not this customer is eligible to buy gasoline. And this is how we want you to decide. If it is an odd day, and if the customer has an odd license plate number, then customer is eligible to buy X amount of gallons of gasoline. On the other hand, computer, if it is an odd day and the customer has an even license plate number, then customer is not eligible to buy gasoline. Okay? Now that is a very simple algorithm. You or I can do that, solve that problem. But what we're looking for is an algorithm or a set of instructions that a computer can understand. That essentially is an if-then statement, right? If odd plate and it's an odd day, serve gasoline. If it's an even plate and it's an odd day, don't serve gasoline. Okay? So that's that example here. Your challenge is to take computational thinking and to try to solve this problem, this question of what is an essential service and what is not an essential service. And so I want you to create one algorithm, but I want you to do a minimum of 3 test cases. So your algorithm is how to decide whether or not a service is essential or not, but I want you to run 3 test cases. So for example, you create your algorithm and you run a test case like buying groceries. Is that an essential service? How does the computer know whether or not that can tell you whether or not that is an essential service? Because you're setting up a set of criteria, right? That if the conditions meet this criteria, then go ahead and execute. Otherwise, don't, okay? So groceries, public safety, so those are your police officers, your ambulance drivers, your fire personnel. Those are other types of public safety services. You can look at medical services. Do hospitals provide elective surgeries? Do they only provide emergency services? Okay. And then even something like, getting your hair cut. Is a hair salon or the place where you get your haircuts, is that an essential service? How do you know? And then maybe restaurants, okay? You run a minimum of 3 test cases, create one algorithm, and then you are done. Hey students, this is Mr. Liu, your 7-Minute Sensei, saying, I hope you stay home, stay safe, and that you are enjoying distance education. So long and peace out.